Okay, class, let's welcome back here. Let's move on here. So the next thing we're going to talk about is a scale factor. Okay, what is a scale factor? Well, I want you to take a look at this ratio and that ratio and see if you see a little bit of a pattern. I want you to start to use your number sense in here and notice this number got magnified by a certain amount and that number got magnified by a certain amount. And if you're thinking, oh, Mr. Keys, that is 10, you're right. That's the scale factor. The scale factor is 10. We multiplied the first ratio by 10 to get to the second one. And I want you to figure out what is the scale factor of this one. What did we do to this fraction to get to that fraction? Well, in this case, 2 times what number is 8? Well, that looks like 4. 3 times 4 is 12. So the scale factor here is 4. You know, these are nice numbers here. These are nice whole numbers. Sometimes scale factors are decimals, so just be on the lookout for that. Let's see about this one. 5 to 10, that looks like a scale factor of 2. 9 to 18, that looks like a scale factor of 2. Again, make sure you understand that, yes, these are initial examples, and these are nice whole numbers. Sometimes scale factors are 1.5 or 7.5 or 2 and 2/3. Just be on the lookout for that. Okay. So let's take a look at a few more ratio problems before we move on. Feel free to pause this and to check out the wording of this problem in here of how to write a ratio. Essentially, that was the answer, but that's not acceptable because it's not reduced down. That's the reduced down version. Notice Shaq hit 4 out of 20 shots. That looks like that's the answer if I'm asking you what's the ratio, but that's not the answer. That's the answer because that's reduced down. This last one in here, Jordan gets 14 out of 16 problems right. Notice that's not reduced. 7 over 8 is reduced down. Keep in mind, you can always write it like that 7:8. However, you can't write it 8:7. So the numerator ends up being the first number here in this format, and the denominator ends up being the second number. Okay, let's talk about another thing in here called what? Extended ratios. So extended ratios look like that right there. So basically, it's extended, meaning we have one number compared to another compared to another. So sometimes it comes in groups of threes or fours or even fives. So when we think about triangles, we have three sides, three angles. So notice this problem says here, triangle ABC. Let me give it some ABC here. Triangle A, B, C have the ratio 2 to 3 to 5. That's their angles. So ABC's angles have the ratio 2 to 3 to 5. What are the measures of the angles? So I drew a little diagram here on how you're going to take this information and translate it into this geometric problem here. So the goal now is to find these angles. In order to find these angles, you got to find x first. Well, how do we find x? Well, the angle sum theorem tells us what? 2x plus 3x plus 5x has to be equal to 180. So when I add up all these numbers in here, this looks like 10 x's equals 180, x is 18. So now all we have to do is back substitute to find all these measures in here. Well, 2 times 18 is 36 degrees. 3 times 18 is 54 degrees. And I think 5 times 18, we did that a few minutes ago, that was 90 degrees. So here are three measurements of angles A, B, and C, 36, 54, and 90 degrees. And notice all three of those angles add up to be 180. Here's another problem, almost identical, except we just changed the extended ratio. The extended ratio here for these three angles are 3 to 4 to 5. So in this case, 3 to 4 to 5, I have 3 to 4 to 5. So I am going to write 3x plus 4x plus 5x all equals 180. So that looks like 9, 10, 11, 12. I got 12x equals 180. I take my calculator out, 180 divided by 12, x is 15, just 15. So when I plug it back in, 3 times 15 is 45 degrees. 4 times 15 is 60 degrees. And remember, all these angles have to add up to be 180. So the missing angle here is 75 degrees. Notice 60 plus 45 plus 75, all of those equal 180. So there's two problems dealing with the extended ratio in a geometric sense. Here's the third and final one in here, and just be on the lookout. Look, this one's already solved for us, but make sure you are, let me move it up here, that you are following along this logic. In this case, we are not finding the angles. They give us the ratio, the extended ratio of the sides. So they also tell us the perimeter is 392 inches. So the perimeter of this triangle has an extended ratio of 2 to 3, excuse me, 2 to 2 to 3. So I put 2x, 2x, and 3x representing those mysterious sides. And I know all together, all three sides, their perimeter is adding up to 392. So that's what I do. I solve for that. I go 2x plus 2x plus 3x, that equals 7x equals 392. And when I divide by 7, I get 56. So in this case, I can find each and every single side. If I do that, I can plug it in. 2 times 56 is 112. That means this one is 112. And notice that's an isosceles triangle. And then I got 3 times 56. That is 168. So I found all three sides at the end. It did ask me, what is the length of the longest side? Well, the longest side here would be 168. All right, let's stop this one and do part 3, and we should be finished up.